In this video we will see method of section, and it is a very useful method because we can directly find force in any of the member inside the truss without jumping from one point to another like in the method of joint. So here we have to cut section into two parts. This is an imaginary section which we have to cut through the truss and apply the equilibrium equations. So here we have to apply the equilibrium equations, summation of x equal to 0, summation of y equal to 0, and summation moment equal to 0 to that section. So now here you see this is the example, and here these are the joints A, B, C, D, E, F, G, and it's a fixed support. Here is a roller support, and there are two forces, F1 at D point and F2 at F point. Now if there is asked the find reaction forces, so we can directly use equilibrium equation through the entire truss like this. And to apply the method of section, we have to find reaction first. So both the questions are solved by the same method. If the reaction forces are asked, then we have to apply these three equilibrium equation to entire truss, or if we have to find them any by the method of section any of the forces, then also we have to first find the reaction. Now if we do summation of fx, then at this point RH will be 0, and by summation of fy we can write this equation. And if we take summation moment at any point A over G, then we can find these two reaction forces. After finding these reaction forces, if it is further asked in the question, then that that find the force in DE. So if it is said that DE force, you have to find force in this member, then we have to cut section such that this DE member should cut like this. You can cut in any angle, but the less the number of members are cut through the section, less number of variables will be there. Like here, if we cut the section like this, then if we take this side of part, or we can take this side also, but there are so many members, so we can take this side. So if we take from this side, then this is the free body diagram. We have to show the forces. If we cut the member, we have to show the forces that is acting in that member. So here three variables are added because three members are cut. So here three forces are there. Now these three forces are assumed to be tensile because we are away from the point, so it is acting on the joint and it is forcing away from the joint, so it is pulling the joint. That's why the member will be in tensile load. So if the forces are come out to be negative, then it is compressive. But here we are first assuming these are the tensile, and we are solving it. So these are three variables added. Now if we take moment at point E, then these two forces are passing through that point E. That's why that moment will be 0. And if we take moment to E, then the F2 RG, which is already found by this reaction forces, and third variable will be FDE. So FDE can easily be found if we take moment at point D. Once we find FD, then apply equilibrium equation, these two equation fx and fy equal to 0, the sum of fx and sum of fy equal to 0, and we can find these two forces also. If we take vertical component of this force and do summation of fy equal to 0, then we can find FDE, and after that we can find summation of fx equal to 0 and find CE. So these angles and length of bar will be given in the question. So from basic geometry we can find all three forces. So this is how we can find force in the DE member. Similarly, these two forces can also be found. And now let's take one more example where they have asked to find BC. So if they are saying the find force in the member BC, then we can cut section like this, same as this. So this will be the forces. And if we see here, first we can find find the here if we take summation moment at B, then we can find the force FAC. So we cannot find directly FBC, but we have to find force AC. Then afterward we have to apply the equation summation of fx equal to 0 and summation of fy equal to 0. So when we take FBC component in vertical direction, that will be equal to RAC. So we can that will be equal to RA, reaction force. Then we can find FBC directly, and FBD we can find after applying summation of F horizontal equal to 0. So to find summation Fy equal to 0, we have to find summation FBC by this equation. So here we can write, if this angle is 60, then the vertical angle will be 30 with the BC, then FBC cos 30, FBC cos 30 will be equal to RA, and we already know RA from this reaction equation. So from here we can find FBC. Once FBC is found, we can take horizontal component sum. So horizontal summation of Fx is FAC plus FBD plus FBC component. This angle is also 60, so cos 60, the FBC cos 60, which will be equal to 0. From here we know FBC, we have found FAC, so that is how we can find all three reaction forces. So this is the method of section, and we'll see some more example later. And thank you for watching this video. See you in the next video.